So you let me know anything. What thing comes to your mind when you listen to the word waves? What are waves actually?
Like the way that sound travels.
The way the sound travels. Only the sound?
Well, the other stuff as well.
Okay. Let's see together, right? Okay. So waves, dear. When I come to the point, what are waves? As you told me how the sound waves travel or something like that, isn't this impression coming to your mind that sound travels in this form?
Yeah,
Wave in this form, right? But what's the reason? How is a light wave different from a sound wave? Do they travel in the same manner? We are going to discuss this today, right? So
yeah,
what are waves? Actually, we'll start with the basic point. What are waves? There, what happens is their waves are disturbances, right? Can wave be generated without a disturbance?
no,
No. So waves are disturbances that are originated when you are going to disturb something, right? Are disturbances that cause transfer of energy, right? I'll explain this anyways. When I write it, I'll explain it, right? Between 2 points which are not in direct contact. I'll tell you how. I'll tell you how. See, dear, think of something that you have water, a pond, or something like that, and you are throwing a pebble in it, right? At this
yeah,
point. Do you find ripples generated?
yeah,
And after some time, what happens? These ripples, they vanish up. Or they vanish up when they reach the bank, isn't it?
yeah,
Here, at the point where the ripples are generated, I mean, I'm talking about this point. Did you create a disturbance at first?
yeah,
Okay. Then you created a disturbance, you just threw some pebble on it. And see the waves, they began to move, right?
yeah.
And when the waves began to move, actually, what is happening? Can I say that the point has some velocity? Velocity is not equal to zero in this case. Yusuf, is it so?
Yeah, yeah.
Yeah. When something has some velocity, what kind of energy does it possess, dear?
Positive.
Yeah. What type of energy then? Positive it is, correct. What type? Is it potential? It is kinetic or something?
Uh, Kinetic.
Kinetic, right? So it has kinetic energy. Now what happens is, now feel this. We saw that the ripples, they go till the bank and they vanish up. What happens at that time? Does the velocity remain the same?
No, it changes.
Very good. What does it become? When it vanishes, I'll say it becomes zero, right?
Yeah,
Now, can I say that at this point, kinetic energy is becoming zero, isn't it?
yeah,
Now, waves were traveling, we don't know. We know that ripples are traveling, right? And what happened is my kinetic energy is reducing from some non-zero value to zero. Now you tell me, can energy be destroyed?
and energy?
Can energy be destroyed?
No.
No. So this energy cannot be destroyed. It has to take some other form. Can you tell me what other form this energy can take?
Uh, I'm not sure.
Okay. This energy that you are talking about here will take the form of potential energy. Are you getting me? Feel this
Yeah.
once. You are getting away from something, and potential energy is the energy possessed when you are moving at some greater height, right? You know this, no? Your
Mm,
position is changing. So your position is changing, this energy gets transferred into potential energy. Are you getting me?
yeah.
Since kinetic is decreasing, it has to change into another form. It took the form of potential, right? Now you keep in mind one basic thing. Kinetic energy decreases, potential energy, it increases, right?
Mm,
Can we come back to the definition again? See this. Waves are disturbances, right?
yeah.
Are they causing transfer of energy in this
Mm,
whole
yeah.
between 2 points, right?
Yeah.
From where? Where they were generated and where they are vanishing off, right?
Mm,
And these 2 points, there is no point of contact. Is there a rope or a string or something that you have connected to join them?
no.
No, there is no direct contact, right? So what do you have in between? You have a medium. Now you got it.
Yeah, yeah.
Now the definition is clear. Okay. Right? Now this is clear, no? What are
Yeah.
waves? These are disturbances that will cause transfer of energy between two points which are not in direct contact, right?
Mm.
One more thing. Feel this now. Since they are not in direct contact, there may be a medium or there may not be a medium, right?
Mm.
There may or may not be present. For example, here I took water as a medium, right? Feel about the sunlight which is coming to us. Is it traveling through any other medium?
No.
No. Originally it is not, but once it enters into atmosphere, it is traveling through air, right? So
Mm.
that wave is very different from the one which is produced in a medium, right? Are you getting me? So
Yeah.
when we have medium, we call it that the wave is traveling in a medium. When you don't have a medium, no medium, that means we call it as vacuum. You know, you must be knowing it, right?
Mm.
Any wave which can travel in vacuum cannot be a sound wave. Is it true?
Yeah.
Yeah. We have a simple example to this. Yeah. You must have done it in junior classes. Can you tell me that example, please?
What example?
Okay. So how is it work is like just we have a bell and we are keeping it in a jar and we are not able to hear it outside when we close the lid, right? Isn't it?
Yeah.
So it's all about that. Now let us come to types of waves, dear. What are the types of waves? Give me the two types of waves that you know.
Longitudinal,
That's good. And
transverse.
that's good. What is the difference between these two waves?
Transverse is in water.
Always?
Yeah.
No, it is not necessary. I'll show you how. Feel this now. Dear, suppose you have a string, right? And you are attaching it to a wall like this, right? And
Yeah.
you give it a jerk over here. You understand?
Yeah.
Like, right? And before you do that, what do is you mark a red point over here. And you will feel that your wave travels in this manner, right?
Mm.
And wave, when it travels, what do you feel this red mark goes? Does it go left, right, or it moves up and down?
Left, right,
Sure. Feel this once. You are giving it a jerk like this,
or
right?
up, down,
Yeah, it goes up and down, right? Now feel this. Where is the wave going?
straight.
Yeah, right. See, can you feel this? Wave is moving along x-axis and the particle is moving up and down, right?
Uh,
So this type of motion is called a transverse wave. And see, you told me that transverse wave is formed in water only. See, I have formed it in air and with a string and the help of a wall, I have tied it over there, right?
yeah.
Okay. Now, can I say that transverse wave is a wave in which particle moves perpendicular, right?
Mm.
To what?
The particle,
No,
the
particle is,
waves.
yeah, to the direction of waves, right? So this is our example. You got it? You
Yeah.
want to give you an example for longitudinal also?
Yeah. Is it when it's parallel?
Yeah, but it is parallel. Yeah, correct. Can you give me an example? Do you want to give me an example?
No.
Okay, let's see. Suppose you have a spring, right?
Yeah.
And again, what you do before doing something, you put a mark over there or tie a small piece of cloth. Now you compress the spring. What do you feel?
It's gone stronger.
Yeah. Now what happens is when you are compressing it, the wave is going here, even the particle is going here, right?
Yeah.
Yeah. So what we observe is the motion of the wave and the particle motion, they are both in same direction. That is the reason you call it as parallel, right? So
Yeah.
can I say that a wave that is formed by a spring, compression or relaxation, that is actually what? It is a longitudinal wave. You got it?
Yeah.
Okay. Now, dear, what happens? I told you one example. No, we started with this sound and light, right?
Yeah.
Can you tell me which one is transverse and which one is longitudinal?
Light is longitudinal and sound is